Math 1314, Tyler Junior College, Section 2.1, Basics of Functions and their Graphs. Disclaimer, what I'm about to show you is not normally part of a college algebra class. However, I'm going to show it to you because for those of you heading towards calculus, you need to think of functions both as functions of x and functions of y. So if you are 100% sure that you will never take a calculus class, you can skip this video and you're going to be okay. For those of you who want to watch it, graphing functions of y. This is just like graphing functions of x. You just have to be a little more careful. I modified the list over here on how to graph it. You select values for y, evaluate the function at each input, plot all the ordered pairs, and then sketch the graph. In general, no matter what the independent or dependent variable is, you select values for the input for the independent variable. For a function of y, the y is the independent variable and the x is the dependent variable. So what do I mean by be careful if we're just doing the exact same thing? Well, here's what I mean. In this one, we're going to select values for y, and I'm going to select the same values as in the previous video, the integers from 3 down to -3. Now this function is actually doing the exact same action as the one in the previous video, where we said f of x equals x squared plus 1. Aside from the name of the function and the letters, these are the same function. Both of them say, give me something, I will square it and add 1 to it. The only difference is these have different names, and then who's the independent variable and who's the dependent variable. And so, since these functions are essentially the same, we should expect the graphs to essentially be the same, but you'll see the difference in just a moment. Evaluating this function at these inputs is going to give us the same outputs as before. Squaring 3 and adding 1 gives us 10. Squaring 2 and adding 4 gives us 5. Squaring 1 and adding 1 gives us 2. Squaring 0 and adding 1 gives us 1. And then for the last three, we're going to get 2, 5, and 10. But here's where you have to be careful. Regardless of who is the independent variable or the dependent variable, this is still your x-axis and this is still your y-axis. And to be totally frank with you, even that is arbitrary. There can be graphs where this is the y-axis and this is the x-axis. I don't think you'll ever actually see that, but it's the choice of x and y was arbitrary. But let's assume that we're going to graph this function on that graph, that coordinate plane. The first ordered pair is not 3, 10. Why? Because the input was the y coordinate and the output is the x coordinate. So this ordered pair isn't 3, 10. This ordered pair is 10, 3. And the next one isn't 2, 5. It's 5, 2. So in other words, we have all the same ordered pairs as before. We're just switching the order because of who was the input and who was the output. So 2, 1, 1, 0, 2, -1, 5, -2, 10, -3. And so when we plot these points, and I'm not going to be as meticulous in plotting them, but 10, 3 is over here somewhere, 5, 2 is about here, 2, 1 is about there, 1, 0 is about here, and then the other three are the same except down here. And we get this parabola opening to the right. Now be careful. This is a function of y, but not a function of x. How can I tell? Remember, in these pairs, these are still x's and y's. To be a function of x, you can't have any repeated x values, which I do. But it is a function of y because I don't have any repeated y values. So it's the same shape that we got before, and if you recall, when it was f of x equals x squared plus 1, it was up here, opening up, and now it's opening to the right. So what does that mean about graphing a function of y that corresponds to a function of x? And again, I'm really pushing the envelope here, but if you take a function of x and just change it to a function function of y, all you have to do is reflect the graph across this diagonal line and you'll get the new one. So for those of you heading towards calculus, be prepared to view functions both as functions of x and functions of y, and stay incredibly focused when you do, because it can be easy to get mixed up.